I wanted to add this particular podcast here because the manuscript, I think, is just submitted. I found it on a preprint archive. I get notified by Google for whatever reason. We have been casually talking about active break periods, MISOs, MJOs, and always imply that there is a relation between MISO and active break periods, for example. And we say MJO is a boreal fall-winter process phenomenon, whereas MISOs are the boreal summer phenomenon. And yet, if you define just the indices for MJO or MISO, you can always compute the indices in any season and get a signal, but that tends to get away from the actual mechanisms. Nonetheless, the role of MJOs in active break periods comes up quite often, and we have already said that the eastward propagating character of the MJO can exist even in the boreal summer months, and we still have debates about whether the MISOs are coming from the western North Tropical Pacific, or they are eastward propagating systems getting detoured northward, and there are ideas that there are multiple flavors of MISOs and so on. So this manuscript uses indices of MISO, which is from the Suhas et al. Paper, which uses the extended EOFs of daily rainfall unfiltered. And you need an index basically because you can do real-time monitoring and predictions, and forecasts are always important for decisions on crop calendars, water, agriculture, energy, and or health, and so on. So this is what Suhas et al. Get. So you are looking at the rainfall signal here, starting with the break period, which has convection on in the tropical Indian Ocean, and there are these large-scale features that we always talk about as well. Remember the 30 to 60 day spatial scale versus the 10 to 20 day interseasonal mode spatial scales were very different, but when we do it this way, we are not separating those two frequencies here. So in phase 2, this is changed here, and you can see that this is showing a northward propagation here, and there are changes in the break period, but you can see that suppressed convection is beginning to occur in the tropical region, and slowly you have transitioned to the active period over land and break period over the ocean. So we have the local Hadley cell and the propagation happening within that. Okay, so there's a nice rainstorm that just arrived here. I hope there is no noise in the recording. So we had similar thing for the MJO, where we went from phase 1 to 8. So you can see the similarity here, phase 1 to 8. This of course is much more recent than the MJO work that's been going on for a while. So you can see again phase 1 active convection in the Indian sector with suppressed convection or a maritime continent. There are other confounding signatures of the IPCZ and other convections in the spatial, temporal scales. So you can see phase 2, 3, 4, the propagation of the convective phase eastward, and the suppressed phase appearing behind it, and so on. So if we just blindly take the indices, in this paper the index for MJO is not the RMM1, RMM2 real-time multivariate MJO index of Wheeler and Hendon. They create their own MJO index, which also uses upper and lower level winds, but instead of OLR it uses the velocity potential at 200 hectopascal. Many people keep creating indices for different reasons. Okay, so this is just the active break cycle seen in the daily standardized rainfall anomalies over the core monsoon zone for 2015. So you can see that there was onset, let's say, and immediately core monsoon zone which doesn't receive the monsoon trough till about a few days later. So you can see the first active period appearing here with the smaller rainfall, positive rainfall anomalies here. Then you have extended break period, an active period, couple of break periods, another extended break period, and an active period at the end before the season ended with the break period. Well, the withdrawal happened somewhere. 2015-16 was a strong El Nino. 2014 was a mild warm event. 2014-15 was one of the rare back-to-back droughts in the Indian monsoon. I think it's the first one since after 1986-87 back-to-back drought. But when you look at the scatter diagram of the MISO 1 and MISO 2 from the extended EOF index for all active and break days during 1998 to 2018, black circle has a unit radius, so typically just like RMM1, when the indices are outside the unit circle, they are strong features with generally higher predictability because signal to noise ratio is higher. So you can see again here phase 1, 2, 3, 4, 5, 6, 7, 8, and here you are looking at the phases and the proportion of active days in which phase they occur. So here in phase 3 you have the most proportion of active days, and then 4 and 5. So starts with 2, ramps up in 3, drops off in 4 and 5. If you look at the break phases, the break phases tend to happen most prominently in phase 6 and 7 of the MISO, which is related to these here. So 6 and 7 seems obvious, and yet you have to be careful. So if you look at the MJO for the same season and look at phase 1 to 8 of the MJOs, you can see that active periods are happening mostly in phase 4 and 5, but there are a fair fraction of active days in phase 3 and 6 as well. So basically here, other than phase 1, all phases seem to have some active days, as opposed to here, which was dominated by 2, 3, 4 and 5. So if you look at the break period again, phase 1 and the 6, 7, 8 dominate, and very few break days during phase 2, 3, 4 and 5. So this is just doing it very technically by using indices, not worrying about whether MJOs should occur during boreal summer or not, and whether they are really identical to MISOs or separate, and so on. And that becomes obvious here when you look at phase composites of rainfall anomalies for 8 MISO and MJO phases during the 10th June, 15th September, 10th June to 15th September for the period of 1998 to 2018. So we are looking at the essentially boreal summer monsoon season. And you can see the MISOs have the feature that we expect, active break periods propagating northward and the cycling, whereas the MJOs, are they really distinct here from the MISOs? You decide for yourself. I included this just to give you a sense of how indices are defined, and then they are applied to look for processes. In a prediction sense, this is okay, because prediction skill, you don't care how it comes about, you just use an engineering approach. If using MJOs and MISOs together in the boreal summer without worrying about the details of the mechanisms can give you skillful active break period predictions, then you don't care. And you can look at the propagations, Haufmuller plots of rainfall anomaly averaged over 65 east to 90 east for MISO and MJO. Sorry, there's a bug here. The superscript became 0. MISO and MJO obtained from the previous figure that I'm not showing here. Phase 5 to 8 to the left of phase 1 to 8 and phase 1 to 4 for the to the right of phase 1 to 8 and repeated Hofmuller diagrams for the display. Okay, so here you are looking at phases and the signals in the rainfall, and you can clearly see the northeastward propagation in the MISO. MJO has somewhat weaker looking signal of the same thing, so there is an eastward propagation, you can say, because MJO has to have an eastward propagation, but there is also this northward tilting signature in phase. So how do you separate them? Obviously then the paper goes on to see how MISOs and MJOs are constructively or destructively interfering with each other during the active and break periods. So there isn't much science there, but I wanted to give you a sense that with all the background we created for the MISOs and MJOs, Indian monsoon offers this complicated challenge of figuring out exactly what MISOs are compared to MJOs, and how they are related to active and break periods. We have also seen the monsoon depressions, where we said monsoon depressions are more likely during the MISO active period in the Bay of Bengal, and monsoon depressions or low pressure systems propagate northwestward into the core monsoon zone and bring substantial amount of seasonal rain, and they are much more in number during active periods. So they are all related, and yet it isn't always entirely clear whether they are the same process or different processes. Okay, so we will leave it here just as an additional point to be made in the context of Indian monsoon interseasonal oscillations.